Okay, welcome to our very last day of review for the first partial exam. And this is what we have been reviewing the past 2 days. Okay, expressions, simplifying expressions, simplifying variable expressions, and evaluating variable expressions. Today, we're going to work with solving one-step equations. We're going to make emphasis today in solving one-step equations with fractions and decimals, okay? I'm going to move this to the side. Remember, we're going to place always the date at the top. That's the first thing. And today is October the 14th, 2021.
Lo siento, estuve perdido como por 5 minutos porque me llamaron de Tigo.
Yeah, don't worry.
Y no paraban de hablarme.
That's okay, Carlos. We're recording the class, okay? Don't worry. Okay, so what are we going to see? We're going to solve one-step equations with fractions and decimals. Let's begin with the one with fractions. With decimals. It's the easiest one. Okay, so let's say that we have, for example, x plus 3.2 is equal to 10.5. Okay, so now remember, we need to leave the variable completely alone in one side of the equal sign. It has to be positive variable in order for us to say, okay, that's my final answer. Variable positive, completely alone in one side, and then everything else on the other side. We pass everything else, every constant or every coefficient with an inverse operation, okay? That's okay, Javier, don't worry. So we're going to pass it with an inverse operation. And again, let's refresh our mind. What's the inverse operation of an addition?
Subtraction.
Subtraction. What's the inverse operation of a subtraction?
An addition.
Addition. What's the inverse operation of a multiplication?
Division.
And the inverse operation of a division?
Multiplication.
And now the extra one that we haven't used yet, what's the inverse operation of an exponent?
Root.
A root. Exactly, a root. So in this case, we have 3.2, which is positive because we're taking into account always the sign to the left of the number, and it goes negative, okay? So we're going to say, we're going to do it like that. X is equal now. We always copy what we have on the other side first, equal to 10.5 minus 3.2. Now, they never, or maybe they teach us this like that, but usually in elementary school, they taught it like vertical. Okay, so we're gonna say 10.5. And now remember, decimal point needs to be aligned with decimal point, both in the additions or subtractions, okay? In the procedure and in the answer. Minus 3.2. And I have here aligned my decimal points, okay? Aligned. You need to be aligned. Now I subtract 5 minus 2, 3. And 10 minus 3, 7. So my final answer is going to be x is equal to 7.3. And that is the final answer for this exercise. All of this needs to be shown in your exam as a procedure, okay? Always show your procedure complete. Why? Let's make an example. Let's say that Alfred did the whole procedure just like it is, and he sent the procedure like that, as it is. But in the exam in Schoology, he got confused, and instead of choosing the option x equals to 7.3, he chose the option x equals to negative 7.3. But he has everything in his procedure like this, and he has the answer positive. It's just that he made a mistake. Okay, so I'm gonna fix that and give him points. Okay, he's not getting 0 out of 3 on that exercise. Okay, he's getting points because he has a procedure. But if he didn't send it, if he just leave it blank, then he misses the points. Okay, so it's important. That's with addition. Let's do another one. Let's say, for example, negative 11.5 plus x, let's use another variable, plus y, is equal to 20.0. Now, again, we're going to leave the variable completely alone on one side. It's already positive, so this needs to go to the other side, but it's going to go doing what?
Addition. Positive.
Correct? You both got it correct? Positive. Why? Because the sign that belongs to the 11.5 is the negative that's on the left of the number, okay? So we're going to have now y remains alone equals to 20.0 plus 11.5. Okay, so we're going to do again vertical, the procedure on one side of our page, okay, or right after, underneath it, that's okay. So 20.0 plus 11, again, align decimal point with decimal point to 11.5. All of this will be added and we'll have a point, a line as well in our solution. Now 0 plus 5, 0, right? No, 5. 0 plus 1, 1. 2 plus 1, 3. So I can say that my answer will be y equals to 31.5 positive. And that is adding or subtracting with decimals. At the beginning of today, I told you where you can find one-step equations with decimals, adding or subtracting decimals, okay? Not fraction decimals. Yeah, and that's it, easy peasy. Now we're gonna do one with multiplication, okay? So let's say that we have 5.2 W is equal to, I don't know, like 8.1, okay? Now we need to have, well, let's say divide by equals to 8.15, okay. 5.2 times W equals to 8.15. What did you say was the inverse operation of a multiplication?
Division.
Division, correct. How do we know that this 5.2 is multiplying the W? Because there is no sign in between, okay, correct. No sign in between the number and the variable. So it will go divided. Okay, and I'm gonna say now, W is equal to 8.15, everything over 5.2. Okay, remember we're gonna use it as a fraction, but we're gonna divide it like normal, okay? And how is normal? The denominator goes on the outside, 5.2, and the numerator goes on the inside of the division box. Now, I cannot work with the decimal point in the denominator in the divisor. I cannot work with a decimal point outside. I don't care if I have decimal points inside. I cannot work with a decimal point on the inside. So what am I going to do? I'm going to move it as many times as necessary to the right to make it a whole number. Okay. So in this case, I'm moving this decimal point one time to the right. But as many times as I move it on the inside, on the outside, I need to move it on the inside. So I'm also moving this decimal point one time. What does that mean? It means that now I have 52, I'm going to put it here to the side. 52 on the outside, and on the inside, I have 81.5 because the decimal point will be between 1 and 5, okay? And then over here, it disappeared. So 52 dividing 81.5. And now I just go ahead and divide as they taught me in elementary school. So remember, we usually say, how many times does 52 fit in 81? One time. And this decimal point that I have, I'll move it up, aligned, because it's still there, it exists. So I'm going to move it up. And I'm going to say 1 times 52, 52. And I change the sign, so it will be a subtraction. 81 minus 52. So 1 minus 2, I cannot do it. I ask 1. That will be 11. Now this is going to be 7. 11 minus 2, 9. 7 minus 5, 2. I drop this 5. And now I ask myself, how many times does 52 fit into 194?
Times 4.
No, let's try a bigger number. Let's try 5. Okay, so 5 times 2, 0. 31. 5 times 5, 25 plus 1, 26. Plus 5, okay? Now I subtract 5 minus 0, 5. 9 minus 6, 3. 2 minus 2, 0. So I won't place anything. If you want, you can place a 0 in there. Or just don't. If it's 0, just leave it like that. Now we haven't finished, but 52 doesn't fit in 35. So I add an imaginary 0. And I ask myself again, how many times does 52 fit in 350?
6.
6 times. And 5 times 2, that's 0. I carry a 1. 6 times 5 is 30 plus 1, 31. And I subtract that. 0 minus 0, 0. 5 minus 1, 4. And 3 minus 3, 0. You see, when I get zeros to the left, I don't write it, okay? As the very last number, I don't write it. If I have it at the beginning, then yes, I have to do it. Or in the middle, I have to write the 0. But if not, just to like, for you to see it. And I'm gonna leave my answer in like that with 2 significant figures, okay? That's called significant figures. And I'm gonna leave it with 2 numbers after the decimal point, even though it can be continued to divide. So my answer is going to be W equals 1.56. And that's the final answer. That's how you solve equations that are having multiplications with decimals. Questions? No? You're refreshing your mind about this? Okie dokie. The last type of equations will be with a division. Okay, so I'm gonna move you guys to this other side. I'm gonna write it over here. And let's say that we have, let's use another variable. Let's use the variable E. So we have E over what? Over 3.77. That will be equal to 2.6. And I will be giving you a fraction. Okay, because divisions, we use them as a fraction. So this is a fraction. So what are we going to do if it's a fraction and you have a denominator? How does it go to the other side? How?
Multiply.
Multiplying, correct, because it is dividing. A denominator means it's a division, so it's going to go multiplying. And you see, I always place over there the type, the inverse operation that I'm going to be using. So now I'm going to have that E is equal is equal to 2.6. And I'm going to use a parenthesis to show that it is a multiplication times 3.77. And now I'm going to do it again, like put aside the multiplication. Remember, for this, we don't care that the decimal points are aligned or not. For multiplications, we don't care if they're aligned. We can just write it like that. See, it's not aligned. And I'm just going to multiply. 7 times 6, 42. I place a 2 and carry a 4. 7 times 2, 14 plus 4, 18. I move one space, and 7 times 2 is 42, carry a 4, and 7 times 4 is 18. And what I align are the numbers, okay? Okay, and now 3 times 6, 18. I place an 8. I move the one space again, carry a 1. 3 times 2 is 6, plus the 1, 7. And I begin to add. 2 plus nothing, 2. 8 plus 2 is 10. So I plus a 0 and carry a 1. 1 plus 1 is 2. Plus 8 is 10. Plus 8, 18. I put an 8 and carry a 1. 1 plus 1 is 2. Plus 7 is 9. Now I count how many decimal points in total I have. In this case, I have 1, 2, 3. So I'm going to place my decimal point from this side, moving 3 spaces. Okay, so 1, 2, 3. My decimal point is going to be over here. Okay, that will be like my decimal point. Imagine
Is that in addition, right?
yeah, this is an addition. On the bottom, it's an addition.
Okay.
So my answer is going to be E equals to 9.802 after the multiplication. Remember, so I multiply, I move spaces, and then all of these numbers, I add them. Then I count how many numbers after the decimal point I have, and that's the amount of numbers after the decimal point that I will have in my answer as well. I have 3, so I need to have 3 as well in my answer. And this is solving equations with decimals. Okay, now one more. Solving equations with fractions. And this I will be doing it handwritten because it's easier to write fractions handwritten, okay? So let's say that I have 2/3 that are multiplying of n.
Miss, the topic, what is solving equations, what?
Solving equations with decimals. And
Please
solving
have a question. That is a 2 or a 6?
That's a 2. It's a really awful 2, but it's a 2. Remember that I'm writing with my mouth, so it's a little bit hard. I'm going to place over here 6 over. Okay. Now, remember, when there is a fraction that is multiplying that needs to go to the opposite side with the division, and this is the only case that we're going to do it, instead of using an inverse operation, we will continue to multiply because it is
And we flip the
multiplied.
fraction.
Exactly, Lino. And we flip the fraction. And I usually write the word flip so I don't forget, but I need to flip. So now I'm going to have n is equal 6 over 5. Now this is a 6 over 5 times, I can use a little dot or I can use the parenthesis. Instead of 2 over 3, I flip it. It's going to be 3 over 2. Now remember, I need to look and try to simplify with cross simplification, which is simplify within the same fraction and simplify the numerator of the first with the denominator of the second, or the denominator of the first with the numerator of the second. That's cross simplification, okay? So I need to try and solve using cross simplification, which is looking for a number that can divide either both numerator or denominator within the same fraction, or numerator denominator with opposite fractions. So can I simplify? Is there a number that can divide and give me a whole number? 6 and 5? No, right?
6 and 2.
3 and 2, no, but 6 and 2, yes. By what number can I divide? I can divide by 2, right? And can I simplify 5 and 3? No, so I'm just going to simplify that. And I'm going to say n is equal to 6 divided by 2, 3. The 5 is not doing anything, so I just copy it like that. Times the 3, I didn't do anything, so I just copy it like that. And 2 divided by 2, 1. And now I go ahead and multiply. And how do I multiply fractions? I multiply them in a straight line, meaning that I multiply numerator with numerator and denominator with denominator. So my answer is going to be n is equal 3 times 3, 9 over 5 times 1, 5.
5.
And since we did the cross simplification, this is the final answer in its simplest form. Remember to always enclose your answers, okay? And that will be like how we need to do when we are solving fractions. Now, the other one is when we're adding or subtracting fractions. There's no way when we're dividing, because this is a fraction, it's dividing, it will always go multiplying to the other side if you have a number underneath it. Then the other one would be adding or subtracting for fractions. I'm going to do only one because we're almost out of time. So let's say that we have positive 4 over 5 plus b, and that will be equal to,
Miss, I have a question. Does a fraction can have an exponent?
yes, fractions can have exponents. We're going to see that further on in the school year. Fractions can have exponents, so yeah. So in this case, 4 over 5 plus b is equal to 1/2. How does it go? The 4/5 to the other side. What would be the inverse operation that has to be used?
Subtraction.
Subtraction. So we're going to say b is equal to 1/2 minus 4/5. Now remember, you can use happy face method or you can use the LCD. We're going to do both. That's why I'm going to do only one exercise. So happy face means that multiplication like that. So I'm going to say b is equal 1 times 5, 5. 2 times negative, there's a negative, remember? 2 times -4, -8. Over 2 times 5, 10. So b is equal to 5 minus 8,
-3.
-3 over 10. That's the happy face method. That will be method 1. Method 2, using the LCD, we're going to start from this part, okay? So we have b equals 1/2 minus 4/5. Remember, we cross a line and we're going to use prime numbers, okay? So what's the smallest prime number that can divide either of those numbers? That would be 2.
2.
2 divided by 2,
1.
1. I'm gonna rewrite that too. We're finished with that number. We copy the 5. What's the next prime number that can divide 5? Well, in this case, 5. And that will be 1. And I finished. Once that I have ones in both, I finished. I multiply this. This is 10. Okay. So this means that b be equal to, I copy the 10 as a denominator. By how much I need to multiply this to make it 10? By 5. So I copy the 5, and between the parentheses, the numerator, minus 5 by how much I need to multiply to make it 10? By 2. And I copy between the parentheses the numerator that I had. Now I go ahead and simplify that, and I get that b is equal to 5 times 1, 5, minus 2 times 4, 8, over 10. So b will be equal to 5 minus 8, -3, over 10. And that's how we get exactly the same answer with both methods. And you can use whichever method that you want. And the same thing goes if you're subtracted, okay? And it goes with the opposite operation, which will be an addition. Question so far? No question. Okay, then. This is the very last part of our review. And now it's up to you to continue practicing for your exam.